So in this class, we are going to discuss about the nth roots of complex numbers, which is an application of the Moivre's theorem. We demonstrate this using examples. And the first example is find the roots to the specific cube roots of unity. Find the cube roots of unity and plot them on an Argand diagram. So what this question means, solution, we need to find cube root of 1, which is the same thing as saying 1 raised power 3. So we let z to be equals to 1 power 1 over 3. So which is the same thing as saying z power 3 is the same as 1. It's like you're solving the equation z power 3 equals to 1. And you know, if you are to this is why you have 1 on this Argand diagram. So this is the imaginary axis. So the angle that's, so remember when you say 1 is the same as 1 plus 0. So complex number 1 is the same as 1 plus 0, I. So you change this complex number into polar form, and polar form requires us to find the modulus. Modulus of this complex number 1 is just 1. And the angle that the line makes with the x-axis is actually 0. So theta is 0, r is 1, and we remember that roots which you abbreviate by wk or even zk are given by r power 1 over n cosine of theta plus 2 pi k over n plus I sine theta plus 2 pi k over n. Then you close the brackets. So where k runs from 0, 1, 2, 3, etc. up to n minus 1. So this is what we derived when we are introducing the concept of roots of complex numbers. So when complex number is 1, then it's very easy to see that r is 1 and theta is 0. So, and we are dealing with k equals to 3, the cube root of this complex number 1. So we'll have wk, r is 1. So 1 power 1 over 1 is just, so we'll have 1 power 1 over 3 cos theta is 0 plus 2 pi k over n is 3 plus I sine 0 plus 2 pi k over 3. So this is what we have. K will be 0, 1, and 2 because we are going, our n is 3, so n minus 1 is 2. So i.e., all the cube roots will be given by w sub k equals to 1 power 1 over 3, just 1. So just have cos 2 pi k over 3 plus I sine 2 pi k over 3. So now, because we are using z as our complex number, then we can just say that the roots will be z sub k. So just to ensure that consistency of the notation. So let's keep the same. So z sub k, z sub k, and then z sub k. Now, so when k equals to 0, because this k should run from 0, 1, 2. So z naught will be cos 0 plus I sine 0, and this will give you just 1. When k is 1, you replace where there's k by 1, so I have z1 will be cos 2 pi over 3 plus I sine 2 pi over 3. This will give you minus a half plus root 3 over 2 I. Then when k is 2, z2 will be given by cos. So 2 times 2 is 4. So 4 pi over 3 plus I sine 4 pi over 3. And this, when you work out, you get minus a half minus root 3 over 2 I. So those are the 3 cube roots of unity or 1. So this is the real axis. This is the imaginary axis. This is 0. Then all these roots will be lying on a unit circle around this Argand diagram. So this way I have 1, this way I have minus 1, this minus I, and this is positive I. So the first root z naught is at 1, and then negative a half is somewhere here, and then negative a half root 3 over 2 will be somewhere here. So this way I have z1, and then negative a half minus root 3 over 2 will be somewhere here. So this way I have z2. And this complex numbers on this unit circle defines actually a triangle, or defines a polygon of sides 3. So you can, in fact, so these 3 actually forms a polygon which is just a triangle. Then example 2, solve this equation, z power 4 equals to 2 plus 2 root 3 I. So to solve this means z is actually going to be 2 plus 2 root 3 I raised power 1 over 4. So it's like getting the fourth root of the number 2 plus 2 root 3I. So always the first step is to find the polar form of the complex number. So R is absolute of Z, which is given by square root of 2 squared plus 2 root 3 squared, which will be 4 plus 2 squared is 4 times 3 is 12. So square root of 16, and you get 4. So R is 4. Then to get the argument, we realize that this complex number is in the first quadrant, where this will be 2 root 3 units, and then this will be 2 units. So that theta is tan inverse of y value is 2 root 3, x value is 2. So the same as tan inverse of root 3. And when you get tan inverse of root 3 is 60, which is the same as pi over 3. So then now z is going to be the same as r, which is 4, cos theta, which is pi over 3, plus I sine pi over 3, and then everything raised by 1 over 4. So we can actually, so let's can call this one just for notation, we'll call it W. So this is R will be, I'm calling this number W. So that now the modulus of W is 4, then theta is pi over 3. So ZK should be given by R power 1 over N into cos theta plus 2 pi K over N plus I sine theta plus 2 pi K over N. And because our N is 4, so K should run from 0, 1, 2, up to 3. So replace accordingly. So we'll have Z sub K, R, which is 4 power 1 over 4, into cosine of theta is pi over 3, plus 2 pi K over 4, plus I sine pi over 3 plus 2 pi K over 4. And specify that K is 0, 1, 2, 3. So when k is 0, z0 will be, remember 4 raised by 1 over 4 is the same as root 2 into, so this is 0, so pi over 3 divided by 4 is pi over 12. So cosine of pi over 12 plus I sine pi over 12. Can simplify that. Then K1, Z1 will be square root of 2. So where does K put 1? So pi over 3 plus 2 pi, so a third plus 2 divided by 4. So we'll have 7 over 12 pi. So I have cosine of 7 over 12 pi plus I sine 7 over 12 pi. Then you can actually give the numerical values of this and write the complex number. Then K2, Z2 will be root 3. So replace where there's K by 2. So we'll have a third plus 2 times 2 is 4 divided by 4. So 13 over 12. So cosine of 13 over 12 pi plus I sine 13 over 12 pi. Then kindly get the numerical values and find the answer. And lastly, K equals to 3. Z3 will be root, this is 2. So root 2 into cosine of, so 3 times 2 is 6, so we'll have 1 over 3 plus 6 divided by 4, so 19 over 12. Then you can get the actual values of those cos of these angles and sines, and then get the numbers or the roots in terms of x plus yi. So that's how we solve that problem. And then lastly, find the sixth root of z equals to -8 and graph the solution. So solution. So z is given by -8, so which can be written as -8 plus 0i. So here, the absolute value is square root of -8 squared plus 0 squared. So the answer is just 8. And if you are to put this number on a number line, so -8 will be somewhere here, this line. So which means that the angle theta is just going to be 180 degrees because it's on the real axis on the negative side. So R is this, and theta is just pi. So that Z can be written as R, which is 8, into cosine of pi plus I sine pi. So the roots, 6 roots, will have zk is r power 1 over k into cosine of theta plus 2 pi k over 6 over n, then just write the general formula, over n plus I sine theta plus 2 pi k over n and k should run from 0, 1, 2, all the way up to 6, up to 5, because now our k is 5. So we'll have zk, r is 8 raised power 1 over 6 into cos. So our theta is pi, so we'll have pi plus 2 pi k divided by 6 plus I sine theta in this question is pi plus 2 pi k divided by n is 6. And specify that k runs from 0, 1, 2, 3, 4, all the way up to 5 because k is 6. So when k is 0, z naught will be 8 power 1 over 6 into cosine of, so 0 here times 2 pi is 0, so we'll have just pi over 6 plus I sine pi over 6. When you work out this, you get the 8 raised power 1 over 6 is root 2. Cos of pi over 6 is root 3 over 2 plus a half I. So when k is 1, means you are going to replace here by 1. What is k? So we'll have pi plus 2 pi, which is 3 pi over 6. So z1 will be root 2 cos of, so 3 pi over 6 is the same as pi over 2 plus I sine pi over 2. And this will give you just root 2 I. K equals to 2 means Z2 will be, so 8 power 1 over 6 is root 2. Then where there's k, put 2. So I'll have 2 times 2 pi is 4 pi times 4 pi plus pi is 5 pi. So I'll have cosine of 5 pi over 6 plus I sine 5 pi over 6. And when you work out, you'll get root 2 into minus root 3 over 2 plus a half I. K equals to 3 means Z3 will be root 2. So put 3 here. So 3 times 2 pi is 6 pi plus pi is 7 pi. So we'll have cos of 7 pi over 6 plus I sine 7 pi over 6. When you work out, you get root 2 into minus root 3 over 2 minus a half I. Then second last root, k equals to 4. Z4 will be, when you do substitution, will be root 2 into cos 3 pi over 2 plus I sine 3 pi over 2. And this will give you negative root 2I. And lastly, when k is 5, Z5 will be root 2. So when you put 5 here, 5 times 2 pi is 10 pi plus pi is 11 pi. We'll have cosine of 11 pi over 6 plus I sine 11 pi over 6. This gives you root 2 into root 3 over 2 minus a half R. So those are the sixth roots of minus 8. And when you put this on an Argand diagram, you'll find that all these points will actually be on a circle whose radius is root 2. So this will have root 2. This one will have minus root 2. This will be minus root 2I. This one will be root 2I. So this is the imaginary axis. This is the real axis. So this is a position where we have our Z0 was, Z1 is where you have root 2I. So Z1 is here. So this way I'll have Z1. Z0 was 2 root 2 times root 3 over 2. So when you have root 3 divided by 2 times root 2, this is roughly 1 point, real part will be 1.22, and then plus root 2 divided by 2, roughly 0.707. So when you, from your graph, you identify that point, it will be somewhere here. So this Z0, and then I remember this angle here. This angle here is pi over 6. And then you also measure pi over 6 and find that the other, this way will have another point here. This way we had Z5. So this measure pi over 6. And then the other value will be here. And this is also pi over 6. So this way we had as our Z4. If you measure pi over 6, this is where we'll get our, so this angle is also pi over 6. This is where we located Z2. And then if you measure another pi over 6, you'll find that the other point will be somewhere here. So this is what gave the other so negative and then positive. That was negative. X is negative, Y is positive. So that is Z2. So this is Z2. And then negative, negative. This is Z3. This is Z3. So this, you realize that if you are to join these points on this circle, they form a polygon. They form a polygon. And these angles are always uniform. I think that pi over 6, 6 of them, when you add, you get 360, which is always true from the basic geometry. So that is usually what we are supposed to do when it comes to finding the roots of complex numbers. It's as simple as convert the key steps that we need in summary. Just change complex number into polar form to have R and theta, which is the argument. Then use the formula that the roots are given by R power 1 over n into cosine of what you have as theta plus 2 pi k over n plus I sine theta plus 2 pi k over n. And this k is restricted from 0, 1, 2. The last value is n minus 1. So this is how we find the nth root. So the only key thing is find R, find theta, and then put those values in this formula, and then you'll be finding each root one at a time. So you count k from 0 up to n minus 1. Good.